So you know when you find yourself stuck at home with a bunch of sodium acetate in the fridge and a laser in your hand? Ugh, Mondays, am I right? I'm Diana, you're watching Physics Girl, and I'm gonna walk you through how to use your sodium acetate and your laser for some fun physics experiments. Okay, let's get started. By the way, a lot of these experiments actually use household items, so most of them you'll be able to do at home. Okay. First experiment. I have here a glass of water and a glass with a mystery liquid. And I've got my violet laser. This is a laser with violet colored lights. I'm gonna shine the laser into glass A over here. And you don't really see much. See a little bit of a violet line. But when I shine it into glass B, I see a very, very bright, clear blue line. Ooh. Which one do you think is the plain water? There's my drum roll. Glass A. Glass A is the water. So when I shine the laser into the water, I can see a little bit of the violet light creating a line through the water. What it's doing is scattering off of some of the water molecules or other impurities in the water. But the mystery liquid is very different. Can you guess what the mystery liquid is? Before I tell you, a quiz. And now's the time of the show where I quiz fruit in my kitchen. Are you ready? Well, let's jam. Here's the question. Since the laser was invented in 1960, what is the coolest use for lasers? Is it measuring the distance to the moon, laser tag, detecting gravitational waves, to give gamers a reality-based way to sight their targets in video games, etching itty-bitty serial numbers onto diamonds, to control and cool individual atoms? And the answer is... yes, laser tag was a close second. You were very close. But the answer is actually F, to cool and control individual atoms. Laser cooling is literally the coolest use for lasers, and it's a real and crazy thing. We can use lasers to cool individual atoms and molecules down to near absolute zero. Okay, back to you, Diana. Thanks, Diana. Now, what is this mystery liquid? It's actually tonic water. Tonic water contains an ingredient called quinine. And when you shine the violet light on the tonic water, it glows, it fluoresces. Check what happens when I shine an ultraviolet light. First on the water, and then on the tonic water. Whew, yeah. So fluorescing is this process where higher energy light, like ultraviolet or violet light, is absorbed, and then lower energy light is emitted. It glows lower energy colored light. So in comes ultraviolet, out goes blue. That's what's happening with the quinine. But regular water is cool too. Here's a fact about water. Of all the water on Earth, only 1% is used for human activities, like agriculture, plumbing, drinking, which means that over your lifetime, you will most likely drink some water molecules that a dinosaur peed out. Cool. Next one. In this container, I have some oil, and I'm gonna drop an ice cube into the oil. Now, my question is the ice cube going to sink, float, explode, or something else? Let's see. Why would the ice cube stop in the middle? Well, this was a tricksy one. I actually poured two different types of oil in here. There's vegetable oil on the bottom and baby oil on the top. So the ice floats right in between, or maybe a little bit lower into the vegetable oil. Now, when the water from the ice melts, it increases in density to nearly 1 gram per centimeter cubed, so the water sinks to the bottom of the oil. The water initially sticks to the cube, weighing it down, and then drips off, and the cube bounces back up a little bit. Now I have a question. If you were holding an ice cube in a boat and the water was dripping off your hand into the bottom of the boat, would the boat go up and down like these ice cubes as the water dripped off and splashed onto the floor? Leave your answer in the comments below. Here's a fun fact about density. If I wanted to fill the tallest building in the world, the Burj Khalifa, with water vapor by boiling water, I would only have to fill 1/10 of 1 story with water and boil that to fill the rest of the 163 stories with water vapor. Although I'd have to fill the story that's the average volume of the rest of the stories, but you get the idea. Another crazy cool fact about density. The densest material naturally found on Earth is a metal called osmium, and it has a density 22 times that of water. Now, how does that compare to the lightest material, aerogel? It's a man-made material, but it's really light. Now, if you had a sugar cube size of osmium, it would weigh the same as 20,000 sugar cube sizes of aerogel. That's crazy. All right, next experiment. This one is really cool. This is actually one of the first experiments I remember ever doing in 3rd grade, but we're gonna do it bigger. Here's another mystery liquid. I scratched off a bit of residue from when I made the liquid, and watch closely. A lot of people call this hot ice, and in fact it is pretty warm to the touch. We measured the temperature before and after it crystallized, and it rose nearly 30 degrees Fahrenheit. So what do you think this liquid is? What is it? Well, it's called sodium acetate, and you can actually make it with adult supervision by mixing a 1/4 cup of baking soda with a liter of vinegar, which we all know makes CO2 gas, which you can actually scoop out and pour out candles with. That's a bonus experiment. But the other stuff you make is sodium acetate. Then you boil that stuff for about an hour and then pour it into a jar, and you can just set that aside, cover it on the table, or refrigerate it until it's relatively cool to the touch. But sodium acetate freezes at 58 degrees Celsius. So what you did when you put it in the refrigerator and let it cool down is you actually supercooled it. You can supercool water below the point where it would solidify into ice. But the thing is, it needs a nucleation site, a place for the ice crystals to start growing. So you can only do that with really pure water. But sodium acetate is really stable stuff. So you can supercool it easily, and then you need to put some crystals like the residue we used, or introduce your finger or shake it around or something like that in order to get it to start crystallizing. And that's hot ice. Diana, I'm so sorry to interrupt with this segment. We have an exclusive interview with this melon. Okay, 2 of these facts are true and 1 is a lie. Can you guess which? Here are the facts. Sodium acetate is used to clean out drains because it dissolves hair tissues. Sodium acetate is used in portable hand warmers. Sodium acetate is used to flavor salt and vinegar potato chips. And the answer is, do you need a life lime? Some help from some other citrus? Perhaps some lemonade? Ah, that is correct! The first one is a lie. Sodium acetate is used to flavor food, and it is used in hand warmers. But it's sulfuric acid that is used in drain cleaner. All right, back to you, Diana. For the final experiment, I have a laser, and I'm gonna put it on this little contraption here to hold it steady. The laser's pointing down at a piece of mirror. The mirror's on top of a balloon stretched over a cup with the bottom cut out, and the cup is taped to a cone I made out of some thick paper. That all is taped to a speaker, and out of the speaker, I'm playing a single tone, a single note. So I have this app called Sonic, and I'm just picking a frequency, like 65 hertz. This is what 65 hertz sounds like. I can go up in frequency, which means the pitch goes up. Here we go. 75, 85. Now, when I turn the laser on and the laser reflects off of the piece of mirror, check out what happens on the wall. Now, if I add another frequency, you get even more complex motion. What we're seeing looks like an animation. It's crazy. Even in real life, it doesn't look like this could be real. So this app, Sonic, only does 1 frequency, but I figured a way to do 2 frequencies by getting a second app called Function Generator, and I played them both at the same time. This is what that would sound like. This is 85 hertz plus 110. Kind of ugly. Here's 85 hertz plus 120. And this is what it looks like. You're seeing the motion of the mirror on the balloon. The balloon is acting like the membrane on a drum, and as sound from the speaker goes up into the cup, it vibrates the balloon, just like sound waves might vibrate your eardrum, and we are seeing that vibrating motion. This is what it would look like with music. This is just a really cool way to visualize the vibrations of sound waves in air. I love this demonstration. Here's another random thing you can do with lasers. If you've ever seen this like hollow material, shine a laser at it. It creates all these dots because this material is actually a diffraction grating. It's a bunch of different little lines etched in to diffract different colors out. But if you just have one color and the laser is just one color, then you'll see a bunch of dots. Hey, thanks for watching. I hope you try these experiments safely at home, and happy physicsing.